So I wanted to do a guiding example with you that will lead us just from estimating the area to actually computing it precisely. So our end goal here is to precisely compute the area of this shaded blue shape. So the area under y equals x squared, this is y equals x squared, let's label it. And we want to find the area under that curve between 0 and 1. And so we're going to begin by approximating it, by estimating it, but then we're going to develop the techniques we need to go ahead and write it down precisely. So let's just start by estimating the area with 4 rectangles. We could have done 2 or 5 or as many as we want. I think 4 is a nice number. So let me just work through the steps with you. So the first step, step 1, is we're going to divide the interval that we're working over. Our interval is 0 to 1. So divide the interval 0 to 1 into 4 pieces, each of which, whoops, I can't spell. Each of which has width delta. Whoops. Delta x, there we go, delta x. We're going to use the Greek letter delta here, delta x. And delta x is always 1 minus 0 divided by the number of rectangles, so it's going to be 1/4 in this case. So let me show you what we're talking about. So we're going to take this interval, and it has length 1. We're going to say, okay, length 1 divided by 4. I'm going to divide this piece into 4 pieces of length 1/4. So here's the first piece. Second piece, my unit is not lining up with my grid, but that's okay. So we'll go like 1, 2, 3, 4. Okay. So the point is, I've broken up the piece of x-axis that I'm working over into 4 pieces, 1, 2, 3, 4, each of equal width. And I just want you to realize that the width of each piece is the same, and we're going to call that width delta x. And don't let that bother you. It's literally just the width of each piece of the x-axis. They're all the same. And so notice that by doing this, by breaking the x-axis up, we actually get 4 sub-intervals of the x-axis. So 4 subintervals of the x-axis. What are they? So you start and you go from 0 out to 1/4. That's this one right here. Then the next subinterval, smaller interval of the x-axis, goes from 1/4. You go out another 1/4 of a unit and you get to 1/2. And that's this one. And then you keep going and you go from, instead of writing it 1/2 though, I am going to go ahead and write it as 2/4. This is one situation where we really don't want to simplify too much. We want to be able to see the pattern. So we're going to go from 2/4 to 3/4, and then our last interval goes from 3/4 to 1. So when you break up the x-axis into 4 pieces, you actually get 4 sub-intervals. And I want to make sure that the general process is clear. Let me switch colors just so that this is somehow clear that it's a little side note. So, in general, the interval, if I have a general interval AB, and I want to break it into n pieces. Now, why did I say n? Because I don't know if I'm going to want 5 or 10 or 100, I want to be able to flex that. So n pieces is just the number of rectangles you're going to have. And, well, you're going to have delta x is b minus a over n. You just divide the length of the interval by n. And then each unit is, when you break up the x-axis, you're going to get a bunch of sub-intervals. And they're going to look like this. You're going to go from a, and we're typically not going to write a, we're going to call it x naught equals a, out to x1. That's your first subinterval. And then you're going to go from x1 out to x2 is your second subinterval, so on and so forth. And then you're going to go out to x sub n minus 1 out to x sub n, and here the last int is b. And so I just wanted to point out to you the notation. So for example, here, if we were going to use this x notation, then this point right here would be x naught, and this point would be x1. This would be xn equals x4, x3. This would be x2. And you might say, why do we need to do that? Well, I need to be able to capture a little bit more generally what we're actually doing here. And so here's the hands-on how you do it in our example. The literal x's that we get are starting at 0 to a quarter, quarter to 2 quarters, so on and so forth. But what's really happening, the language that I need to describe it in general, is b minus a over n, and then I'm just going to have these endpoints of the subintervals, x naught to x1, x1 to x2, so on and so forth. Okay, so let's label clearly what we have. We're going from 0 to a quarter, and then 2 quarters, and then 3 quarters, and then out to 1. All right, so let's stop this video here, and in the next video we'll form our rectangles.